that's the problem. Okay, how are you guys? Can you hear me? Can you hear me? You guys good in here? You guys good out there on the grid? You're good? Okay, if you can turn on your cameras, guys. Turn on your cameras. My stupid iPad ran out of memory in my morning class, and I didn't realize that. So I've got to, I guess, start recording the Zoom just as a backup. Okay, we are not going to have a quest this week. But we are going to have a quest next Friday. Okay, and it will be related to a lot of these derivatives that we've been taking. We will have a WebAssign due on Friday. Okay, the WebAssign keeps you doing your homework. WebAssign. Okay, so stand up. I can tell everybody needs this. Colin, you should be standing. Lindsay, Trey, you guys can get your videos on, guys. Anybody can get their videos on, get them on so I can see your faces. Okay, stretch. Okay, let's sit back down. I have your stuff graded. I'll give it back on Friday. I don't have it all graded. There's a couple I still need to grade. There's a couple who have COVID and just still need to recover enough to take the quest. It's just one of those semesters. Okay, how many people kind of understand chain rule? A little bit. Quotient rule. Product rule. Tangent line. When I say tangent line, you say primacy times x minus c. So yeah, these are things that we want to have. So we haven't talked much about applications. If I do this, are you guys still good to take notes? Are you guys still? Okay. We haven't talked much about applications. We have one application right now for the derivative. Calculus is about limits, derivatives, and integrals. Oh my. Okay, our one application that we have for the derivative is it's the slope of the tangent line. The derivative is the slope. It's not the tangent line. But it's the what of the tangent line? Slope. But that's not the main application. The main application for the derivative is related to rate of change. Okay? So I'm going to write on the board. Two different rates of change that you guys are going to have to know. One is called the average rate of change, and the other is called the instantaneous rate of change. So what are the two rate of changes again? Average and instantaneous. Okay, so let's get those definitions in play. So in both cases, I've got a function. And on the first one, I've got a closed interval. My domain is between A and B. And so if I've got a function f on a closed interval, what's the definition of a function again? I hate you, Dr. Warren, is not the definition. What is the definition of a function again? A relation that assigns to each element in one set called the domain a unique element in a second set called the range. Okay? Now I've got a function on the domain, which is the closed interval AB. So we can also think of this like in old elementary school ways as being that closed interval right there, as being that closed interval right there. And we say, this is a number, it's called the average of f. The average of f is the average rate of change of f on the closed interval AB if the average of f is equal to f of b minus f of a. There's a minus sign there. F of b minus f of a over b minus a. This is our definition. This is our definition of the what rate of change? This is our definition of the what rate of change?
Average.
Okay, and let me read it again. The average of f, that number, is f of b minus f of a over b minus a. And that looks awfully familiar, guys. If you think about y2 minus y1 over x2 minus x1, that's the what formula. That's the what formula from high school. Slope. So this is really like a slope. So now what I want you guys to do is draw an xy axis. Draw an xy axis. And in the domain on the x-axis, mark an a and a b. Mark an a and a b, with b bigger than a. So draw an xy axis. Draw an xy axis. And mark an a and a b on the x-axis in the domain. Now I want you to draw a function that's actually a function. It passes the vertical line test. Draw a function. Draw a function. Now let's go back to week 1. Mark f of a on the y-axis and mark f of b on the y-axis. So you've drawn an xy axis, you've got yourself an a and a b, you're drawing yourself a function, and you're marking f of a and f of b on the y-axis. So this is active learning. This is active learning. You guys are doing the learning. You're not just writing. Now mark the points, mark these 2 points on the function. The point a f of a. Mark the point a f of a on your function. And guess what the second point you're going to mark on your function is? B f of b. So mark that. Mark a f of a and b f of b. Okay, now draw the line that's going between the point a f of a and runs straight through the point b f of b. You've drawn those 2 points on your function. Draw a line that runs between a f of a and b f of b. Okay, now what I want you to do on the grid is go to grid view. Go to grid view. Go to grid view. Go to grid view. And hold up what you have nice and still so other people can see it. Hold up what you have to the camera nice and still. And you guys do that in the room. You guys look around. You see if you've got the same thing that other people have. See if you have the same thing that other people have.
Pretty much, yeah.
Okay, go back and make me number 1. Go back and make me number 1. Okay, the first thing I asked you to do was what? Let's go back to what we were just doing. The first thing I asked you to do was, so this is what I've got. I've got my x-axis. And what was the next thing I asked you to do? So I've got my a, my b is bigger, and then what did I ask you to do?
Draw a function.
Draw a function. So maybe my function looks something like this. Your functions look different. I've got to ask, is that a function? Did I draw a legit function? Is that a legit function, guys? Is that a legit function? Yeah, it passes the vertical line test. What was the next thing I asked you to do? F of a and f of b. Before you were in this class, you didn't know, go up, go over. That would be the value, f of a And then I go up, play that same game of catch, unlike the Braves, playing like the Dodgers right now with this game of catch. This would be f of b. Then what did I ask you to do? Then what did I ask you to do?
Label points.
Label points. Label this point and that point. This point would be the point, this point would be the point, bf of b. And then similarly, this would be the point a f of a. Now, what was the next thing I asked you to do? What was the next thing I asked you to do? Draw the straight line going between those 2 points. If you have 2 points, can you get the slope? If you have 2 points, can you get the slope?
Yeah.
So let's find the slope of this line. Let's find the slope of that line. The slope of that line would be y2 minus y1 over x2 minus x1. But here, who's y2? Who's y2? Who's y2? Well, we'll just keep it consistent with the thing there. F of, good minus f of b. Then it'd be f of b minus the y coordinate of the second point, which is fa, divided by x2, which would be b, then minus a. Do you guys see how the average rate of change, do you see how the average rate of change is just the slope of the line going between the 2 points on the function? Can you visualize that? Okay, slope represents some kind of rate of change. Now notice that, well, I guess, we haven't done any units in here yet. Let's do this. Let's suppose my domain has units of what? You guys get to pick it. Suppose my domain has units of what? My domain has, there is no wrong answer. I'll make anything work. My domain has units of 3. I need something that would be, I need 3. I need something that would be something I could count. And I can't count 3. I can count to 3. Apples. Okay, so my domain has units of apples. Okay, so my domain has, and then my range, something that might depend on apples. Something that might depend on apples. What was that? Pi, okay? So this is going to have units of pies. Okay, so we got pies. Okay, so for example, if I say f of 10 equals 2, interpret that for me. Now suddenly our math has meaning, because now we have units. F of 10 equals 2. Turn that into English for me. What does that mean?
10 apples is 2 pies.
At 10 apples, I get 2 pies. At 10 apples, I get 2 pies. Now imagine I said, okay, well, f of 15 is equal to 7. Suppose I say f of 15 is equal to 7. Interpret that for me. Interpret the math now. What does that mean? At 15 apples, I get 7 pies. You're like, holy heck, Dr. Warren, this is not the scenario I thought we would have. Can you calculate the average rate of change of this function? Can you calculate the average rate of change as I go from 10 pies to 15 pies? Can you calculate the average rate of change as I go from 10 pies to 15? And maybe I'll ramp this back. Maybe I'll take it to 6. Maybe I'll take it to 6. Just change it so I don't want the answer to be 1. So you guys do that. At your seats, in the grid, the same thing. At your seats, find the average rate of change. Find the average rate of change on the interval 10 to 15. Find the average rate of change. What's the average rate of change of your function on that interval? Okay, when you're done, tell me what your answer was. Tell me what your answer was. When you're done, tell me what your answer was. What'd you guys get? What'd you get? What'd you guys get? 5 fours. 5 fours. How many people got 5 fours? How many people got 5 fours? Okay, if you're looking at it, it'd be f of 15 minus f of 10. Anybody have that? Did anybody have that? Anybody have that? Then divided by 6 minus 2. Okay, now guys, if we think about that, if we come back here, it's f of b minus f of a over b minus a. So what would be in the denominator? Not 6 minus 2, but what's in the denominator? 15 minus 10. See, we want to, this is why we're doing this. This is what, they're what goes into the function. They're domain values. They're domain values. So if you're looking at that, then what would be f of 15? Well, f of 15 is 6. F of 10 is 2. And what's 15 minus 10? 5. So this would not be 5 over 4, but 4 over 5. 4 over 5. How many people are understanding that? At least that much. Now here's the thing. Let's interpret this. What are the units of 4/5? What are the units of 4/5? Well, let's come back here. It's f minus f, but f is coming from the domain or the range of the function. F of b minus f of a, is that coming from the domain or the range? The range. It's their values that are on the y-axis. B minus a, those are values that are in the domain. What are the units of this axis? What are the units of this axis? In this scenario, what are the units of this axis? Apples. What are the units of this axis? Pies. So if I'm looking at this 6 minus 2 is 6 what? This is important. This is where the applications come in. I know it's not easy. 6 pies. This is 6 pies minus 2 pies. This 15 though is 15 apples minus 10 apples. So this really has units of pies per apple. And there's the rate. So this is 4/5 pies per apple. Now let's interpret this. Let's write down a sentence that's English that describes the average rate of change. And so that's what I'm going to do. And right now, I just want you guys standing up. I can tell already we need to stand up. Okay, let's just slap our face. We can't give ourselves COVID. Slap our face. Okay, slap our face. Say, wake up. Wake up. You guys say it at home. Wake up. Okay, I believe you. I can hear you. I can hear you. Okay, sit back down. Lorelei was going to do it. She was actually going to say, wake up. Now, what were we doing? What did I say we were going to do? Nobody remembers. Turn it into a sentence. I'm going to turn this into a sentence. And you guys are going to write down, and then we'll say it again. Okay, here's the sentence. My average of f being equal to 4/5 means as I go from 5 apples as I go from 10 apples to 15 apples, the number of pies increase at an average rate of change of 4/5 a pie per apple. Now, I will read it again because I know you guys at home can't see it. I'll read it again. The average of F, this is average of F, sorry. The average of F, the average rate of change being 4/5 means as I go from 10 apples to 15 apples, the number of pies increase at an average rate of change of 4/5 a pie per apple. 4/5 a pie per apple. Okay. Now, what I want you guys to do at home, is go into Canvas, go to Files, and open the thing PDF called Girlfriend Plot. And I'm gonna do the same thing. I'm gonna pass this out here. Sorry, I'm passing out 6 kids here. Oh, thanks, Miles. Okay. All right. So now guys, this is, look at that plot, okay? And you guys at home are gonna try to answer, we have 4 questions here. Now, I'm gonna help you out. My range units. Do you see that line called range units at the top near the X, near the Y axis? Do you see the thing called range units? You guys see that? Okay, so just draw an XY axis if you're at home. Draw an XY axis if you're at home. The range units are miles. The domain units, and there's a little line down there, is hours. So what's going into the function is being measured in, what's going in is measured in hours, what's coming out is miles. Going in is coming out is miles. Okay, so let's just look at the graph. When he was a quarter of an hour, f of 0.25, f of a quarter of an hour would be equal to what? If you're just reading the graph there, f of 0.25, write down what you think it is. Don't say it out loud. Write down what you think it is. F of 0.25, now say out loud. What do you think it is? F of 0.25 is what? 3 miles. 3 miles. This is 1/4 of a hour. 1/4 of an hour. Okay, so now look at f of 1. F of 1 is what? Look at the graph. F of 1 is what? -2. And you're like, Dr. Warren, what does that mean? -2 miles. Okay, well, imagine that I've got a road. Imagine that I've got a road. What did I just say at home? What did I just say? You got a road. I pick a certain part as a starting point. Could I travel this way on the road or that way on the road? Could I travel this way on the road or that way on the road? So if I think about one direction as being positive, then if I move 5 miles this way, that would be a displacement of 5. If I move 5 miles that way, I can't just say 5 miles. I can't say go 5 miles. Because the guy doesn't know. He comes out and he's like, well, what the hell are you talking about? Do I make a left or do I make a right? You know, you got to tell them a direction. So we're going to use positive to mean we're going this way, negative to mean we're going that way. Does this make sense? Does this make sense? So now, look at f of 2. Find f of 2. What's f of 2? Look at f of 2. See if you can at least interpret that. Find f of 2. F of 2. F of 2 is what, guys? F of 2 is what? 5. Okay, so now what I want you to do is answer the following 4 questions. Answer the following 4 questions. You're asked to find the average rate of change on these following intervals. The first interval is A is 0 and B is 0.25. The next interval, A is and B is 1, and so on and so on. You guys have to find the range values. Try to find the average rate. Take about 10 minutes and try to find the average range. You may want to take your phone out you might need a calculator. For at least one of them, you might need a calculator. The rest of them, I don't think you'll need a calculator
For
for.
the units blank, is that just like miles per hour?
All the units are going to be miles per hour. Very good, Miles. Sorry. Couldn't help but laugh at.
Yeah.
Try to answer those average rate of change questions. Okay, you guys are going to breakout rooms, you're going to breakout rooms, you're going to breakout rooms. You're gonna compare answers, you're gonna compare answers. Okay, and you guys are gonna go to breakout rooms or two, you're gonna or just three, whatever. Just read your answers to somebody, read your answers to somebody, see if you're getting the same thing there. See if you're getting the same thing. Without breathing too much, without breathing too much.
Yeah.
1.75.
I got negative 12.
Yeah, I think I did it.
Yeah. Cause, unless I read it wrong, because I know I did the fourth one, and I had to redo it. Cause isn't F of B 1.5?
Yes.
And then F of
It's
A
right over there, right?
is negative 2. So 5 minus negative 2, or does that make negative 3? Oh my god, because I did write it down wrong. See, I know I messed up. What'd you say you got for it? Okay.
Okay, let's see how we did. What did you guys get for number one? What did you get for number one? Did anybody get anything for number one? 12. How many people got 12? How many people got 12? Okay, and that was 12 miles per hour. So on the interval 0 to a quarter of an hour, the average rate of change was 12 miles per hour. Oh, you gotta be. I hate this thing. Sorry guys, I've only had one of these for a year. I still don't know how to work it. Okay, this was number one. How about number two? Number two, on the interval from 0 to a quarter of an hour to 1 hour, what'd you get as the average rate of change? What'd you get as the average rate of change? Negative 6.666 on forever and ever and ever. And again, this is what? Miles per hour.
Wait, so could we write that like negative 6 2/3?
You could write that as negative 6, that'd be fine. Okay, how about number 3, going from 1 1/4 hour to 1.5 hours. What'd you guys get as the average rate of change? 28. And then the last one, when x is going between 0 and 2.5, overall, over the entire time period, on average, how fast was he going? 0 miles per hour. And you're like, okay, Dr. Warren, okay, I mean, I get this. But guys, isn't this the way we think about time? I mean, if we think about it, if you're gonna drive to Florida for spring break, let's say you're gonna drive to Florida, and let's say it's 1,000 miles. And it takes you 10 hours to get there. Somebody could ask, on average, how fast were you going? On average, how fast were you going down 95? It's 1,000 miles to get down to Orlando, and it took you 10 hours. On average, how fast were you going? 100 miles an hour. Like, okay, Dr. Brown, that seems reasonable to me. Okay, number guys. 81 on 81 used to be what in this state? 81 on 81. You get caught going 81 on Interstate 81. That used to be what? Reckless operation until this summer. Every other road in Virginia, it was 15 miles an hour over was reckless op. You got caught going 10 on 81 over, that's reckless up. And at 20 years old, reckless up, you know what that does to your insurance? You know what that does to your insurance? Destroys your insurance. It means Saturday school. It means Saturday school to get your insurance not to go up, to lose that point. Saturday school. But now they changed it to 15. Now they changed it. And here's the thing, guys. I've been driving for since I was 16. I forgot. I'm 16. I'm now 60. Okay, so I've never gotten picked up going 9 miles an hour over. I've gotten picked up 4 times going 10 miles an hour over. So I think the magic number is 9. I think the magic number is 9. But enough of me teaching that. Enough of me teaching that. Let me just go back to what we're talking about average rate of change. And what I want, the point of this scenario is, I want to like you to make sure you guys understand that average rate of change isn't a great way of talking about rate of change. What did I just say? Yeah. So let me just okay. So there's a couple of other lines. There's a couple of other lines on this thing. So what right there at the origin? Do you see that line? Let's fill in this. Write down Miles' house. Write down Miles. Maybe not Miles since we got that. Shay's house. Sorry, Shay. I'm taking you're going under the bus. Write down Shay's house. Write down Shay's house. Okay, now at -2, write down Shay's old girlfriend's house. Write down Shay's old girlfriend's house. Now up at 5, I want you to write down Shay's new girlfriend's house. Shay's new girlfriend's house.
Okay, Shay, get it.
So I want to discuss, I want to say that average rate of change just ain't going to cut it. Because we're thinking that Shay's here, Shay's house is here. This is where Shay's house is. Shay, is this the way you spell it?
Yeah.
Okay. And so down here, how far is Shay's old girlfriend's house from his house?
2 miles.
Well, it's not, 2 miles, but when he comes out of his driveway, does he go right or left? Does he go right or left? He comes out of his driveway, does he go right or left? Right, so this is 2 miles away. We got his old girlfriend's house right here. This is the old girlfriend. Okay? Up here is the new girlfriend. How far is Shay's new girlfriend from his house? 5 miles. So now let's go back and look at our rate versus time graph. Let's go back and look at our rate versus time graph. If I'm looking at it, okay, what happens in the beginning? Let's just think about it. What's happening here's the scenario. Now we're not going this way, guys. It's not X versus Y. He's just going up and down this road. This is all he's doing. Over the 2.5 hours, all he's doing is either moving this direction on the road or he's moving that direction on the road. Now over the first quarter of an hour, over those first 15 minutes, he took off on his bike and he did what?
Fell.
No, he didn't fall. What did he do? Over that first quarter of an hour, where was he? What was F of 0.25? What is F of 0.25? 3. So he got out in that first quarter of an hour and he went towards his new girlfriend's house. Now what happened for the next 5 or 6 minutes?
He just stayed there.
He just stayed there. Thinking. Then what did he do? Look at the graph. Then what did he do? He went back this direction. Got about 1 mile from his girlfriend's house, and then what did he do? Stopped. Thinking. And then what did he do?
Went to his old girlfriend's house.
Okay, and then what did he do? Stayed there.
Question for Shay.
For how long?
For a while.
Half an hour. Then what did he do? He went, and then what did he do?
Stayed there for about an hour.
And then what did he do?
Went back home.
Went back home. Okay, so now his mother comes in. His mother comes in and goes, so what have you been doing for the last 2.5 hours? What have you been doing for the last 2.5 hours? And he's like, on average, nothing. On average, nothing. Do you see how average rate of change just ain't a good description of what's taking place in the moment? Do you see how average rate of change just does not describe what's taking place in a moment?
Yeah.
Even going to Florida, do you get in your car, turn the ignition, and then instantly go 100 miles an hour? I mean, that would be fun, right? I mean, did we actually get there? I was going 100 miles an hour when I was in Florida. I mean, could you imagine that? You got in your car, boom, 100 miles an hour, boom. And then imagine you're ready to stop. You're going 100 miles an hour, and then immediately go to 0 miles an hour. Would that hurt? Would that hurt? Would that hurt? See, average rate of change doesn't really describe what's taking place in the moment. Average rate of change fails to describe what's taking place in the moment. Part of the time was he increasing. I mean, if I think about increasing, moving in this direction, part of the time was he moving in the positive direction toward his new girlfriend. Part of the time was he decreasing, thinking as the old girlfriend, not being negative. I'm not saying picking positive or negative. I'm okay. Okay, but if we're moving this direction, his rate would be decreasing because we're moving in a negative direction. He was moving back and forth this whole time, which we pick up on smaller and smaller time intervals. Now, how do the police actually check your speed? How do the police actually check your speed?
Speed gun.
A speed gun. How does a speed gun work? Dr. Warren, it's magic. You just bing, it tells my distance. How does a speed gun actually work? They used to call them radar guns. But now they use lasers. Okay? And so what they do is they'll have a gun. It actually shoots out 2 laser beams. One goes in this direction, one goes in a direction like that. They calibrate it, and you come across with your car here, you break that laser, it's recorded, that time is recorded, and then when you break here, that time's recorded. They know this distance, and so again, they're using average rate of change. This distance over that time, to approximate exactly how fast you're going. But it's such a small amount of time. That they consider it to be your instantaneous rate of change. How fast you were going. Did you ever see the things, be careful, your speed is being checked by aircraft. Have you ever seen those signs before? Have you ever gone down the road and you're like, what the hell? I mean, then you start driving, you're looking out a window. Where's an aircraft? And you're like, how do they actually do that? Well, what they'll do is they'll look at a mile marker. They'll have another mile marker, and they're up there with a stopwatch, and they're counting how long it takes you to go that distance. And again, they take your distance and they divide it by your time. And if it's over 100 miles an hour, you're going to get a ticket, and you're going to lose your license. My brother knows. My brother Doug knows. He one time got a ticket going 125 miles an hour on a 55.
How's Doug these days? Is he good?
What?
How's Doug these days? Is he
How?
okay?
Doug's okay. He's bless his heart. Yeah, every time I go home, I learn something new about my brother. Every single time. Everything I think I've got it all. And every time I go home, there's something new. What was he telling me the last time? Oh, he goes, when he's working at a grocery store now. I think he's back. He used to be bagging, now he's back cutting meat, I think. But people who would talk to him and ask where he was from, and he's in Florida now, and they would talk about what degrees he had, and he said he spent 2 years at NYU, and he spent 2 years at FSU. That's what he tells them. I spent 2 years at NYU and 2 years at FSU. And they're like, you spent 2 years, you spent 2 years at NYU and he goes, yeah, New York unemployment and Florida State unemployment. That's been my education. I'm just like, how can you come up with that? How can you come up with that? Yeah, no, okay, all right. So instantaneous rate of change. I gotta land this in 2 minutes. I gotta land this in 3 minutes. Are you with me? Can you hang? Can you hang with me? Can you hang? So imagine that I've got some distance versus time. Okay, and I kind of would like to know what's happening right at this point C. I'd like to know how fast I'm moving at this point C. This is F. This would be the point, this would be the point, this would be the point F of C. Now I'm going to do the radar gun trick. I'm going to take a very small amount of time. I'm going to move over from C to a point T. I'm going to move over from C to a point, what did I just say? Some of you guys are just so zoning. I could actually remove some of your wisdom teeth right now, and you wouldn't even feel any pain. That's the coma that you're in. This would be the point, F of T. Now, if I look at the average rate of change, it would be this distance minus that distance, which would be F of T minus F of C. And then over the time interval, which would be T minus C. Now, the smaller this time interval gets, the closer T gets to C. What did I just say? The smaller the time interval gets, the better the approximation gets to your actual speed. Does that make sense? And in fact, if I could take the limit as T goes to C, that would actually be how fast I was going. You're like, Dr. Warren, hey buddy, that looks familiar. Dr. Warren, that looks a bit familiar. Dr. Warren, what is that, guys? What is that? Does anybody know that? What is that? Anybody have any idea what that is?
Is that the definition of derivative?
Very good, Miles. Say it again, Miles.
Definition of.
Miles, come on up here, man. You're gonna close class down. I want you to just do the Dr. Warren right in the camera. Do the Warren Doctor right in the.
That is the definition of a derivative.
Thanks, Miles. Let's give it up for Miles. Come on. Guys, this is F prime of, by definition, this is F prime of C. F prime of C is equal to the limit as x approaches C of f of x minus f of C divided by x minus C. Is that not the same thing? Is that not the exact same thing? So instantaneous rate of change is the definition of the derivative. The derivative is the instantaneous rate of change. Say that. In the book, they just call it the rate of change. They don't even use the word instantaneous. When they ask for the rate of change, they're asking you to take the... You don't even need to use the definition anymore. Do we have flashcards? Do we have loads of flashcards for derivatives? When they ask for the rate of change, they want the derivative. When they want the average rate of change, you've got to use your slope function. You've got to use your slope function. Average rate of change, slope function. Instantaneous rate of change, derivative. Average rate of change, instantaneous rate of change, derivative. Is this making sense?
Yes, I have a question.
Yes, Miles.
So the average rate of change is capturing from what happens here all the way to here, right?
Yes.
And so how is that different from what is the instantaneous capturing?
The instantaneous is at a point. It's like at a
At one-
specific second in time.
Alright.
How fast are you moving right there?
I got it.
Versus how fast were you moving over the entire interval?
Yeah.
Those are two very different questions. Usually what's happening in the moment's more important than what's happening on average. You know, it's like with Che in soccer. You know, it's not like, well, how fast was Che moving up and down the field over the entire game? That's not important. How fast was he striking at, I know nothing about soccer, so. How fast was he like kicking? Okay, I know nothing, but I assume there's something.
So,
Okay, all right, guys. I've already have you over time. I have you over time. Be safe, be safe, be safe.
Thank you.
Thank you, guys, thank you. I can never remember to do that Live Safe app. I just cannot remember to do it. I'm such an idiot. No matter what I do, I tell myself every morning, take your temperature. And every day I forget. Lane, no. Lane?
Yeah.
Oh, okay, there we go. Jacob? Chris?
Thank you.
Thanks.
Have a good one.
Thanks, guys.
Thank you, have a good one.
Thanks for playing, Jay.
Yeah, for sure.
See Miles.
alright,
Thanks for getting up there.
yeah, for sure.